1 light year is the distance a light ray travels in a year and is about 10 trillion kilometers. The modern image of the universe reveals a huge, complex, and impressive environment, whereas we exist and evolve on the surface of a small but hospitable planet called the Earth. Earth is the only oasis of life, at least on our solar system. The conditions prevailing on its surface allow the existence of huge amounts of water in liquid form, both in the seas and on land. Water in liquid form is the most essential ingredient for the formation and development of the phenomenon of life. Limited to the environment of our planet, we have so far been able to visit and explore only the very near celestial bodies, such as the Moon and the planets of our solar system. But how did we manage to study the universe at such enormous distances and understand its content, its structure, and its evolution? How did we unveil many of its secrets? Unfortunately, only few people know that all this knowledge is gained by the collection and analysis of the dim starlight that reaches the Earth from those remote heavenly bodies known as stars. This adventure actually began in 1609, when the Italian scientist Galileo Galilei turned a small homemade telescope to the sky for the first time. His observations opened a huge window to the universe and revealed its greatness. The optical telescope operates in the same way as the human eye. The telescope collects light and focuses it on a single spot. There are refracting telescopes, which employ lenses, and reflecting telescopes, which use concave mirrors to collect and focus the light. The amount of the collected light depends on the area of the lens or the mirror of the telescope. A large optical system collects more light and thus makes visible dim celestial objects which are invisible to the human eye. Most dim objects are invisible because they are distant. Their image traveling at the speed of light takes a long time to cover the enormous distances. Thus, when we observe them through the telescope, we see them as they were in the past. In other words, a telescope is a kind of time machine that allows us to observe the universe as it was in the past, and thus understand its evolution. As time passed, the telescope evolved from Galileo's simplistic instrument into huge technologically advanced and precise scientific instruments. Today, we use large optical telescopes placed strategically on remote mountaintops all over our planet. Far from urban areas, they avoid light pollution, which prevents astronomical observations. Furthermore, in the high altitudes on mountains where they are built, the atmosphere is much more transparent and stable. The larger telescopes in the 8 to 10 meter range aperture that are used by the American astronomers placed on Mauna Kea in Hawaii. The European Southern Observatory has erected the Very Large Telescope, VLT, on Cerro Paranal in the Chilean Atacama Desert. This telescope consists of 4 reflectors with a diameter of 8.2 meters each. The Atacama Desert is one of the most arid places on Earth, thus providing ideal conditions for astronomical observations. These telescopes can observe in optical and infrared radiation and can record objects 4 billion times dimmer than those that can be observed by the naked eye. They weigh hundreds of tons, but are capable of pointing and tracking celestial objects with extreme accuracy. They also employ adaptive optics, which can compensate for atmospheric disturbances. And are equipped with many auxiliary instruments such as light-sensitive cameras and high-technology spectrographs. These large telescopes are mostly used for the study of large-scale structure and the evolution of the universe by observing the remote clusters of galaxies and the interaction between their members. Alongside these giant telescopes, the older and smaller telescopes continue to contribute significantly in scientific research. In the near future, new giant Earth-based optical telescopes such as the European Extremely Large Telescope ELT will be available to astronomers. It will have a 40-meter diameter segmented mirror and will be erected at Quero Armazoras in the Atacama Desert in a few years. Yet, in spite of all these technological advancements, we still cannot eliminate all the problems caused to astronomical observation by the Earth's atmosphere. Thus, we had to put telescopes in space out of the Earth's atmosphere. Until now, the biggest space telescope is Hubble, which has a mirror of 2.4 meters. Since 1991, Hubble observes the universe with unprecedented accuracy and is credited with many important discoveries.